Clean type heat recovery coke oven is a type of oven that has developed rapidly both domestically and internationally in recent years. It has several typical process characteristics that enable it to use feed coal with lower caking properties and possess the capability to significantly reduce raw material costs. Firstly, because its coal charge is stamped flat and horizontally, under normal conditions, its stamping density can reach around 1.15, which is more than 0.1 higher than that of traditional stamping coke ovens. The width of the coal charge in conventional coke ovens is about 0.5 meters, whereas the width of this coke oven's charge is typically around 3 meters. The width of the gap between the coal charge and the oven wall is basically the same for both oven types. Moreover, during the heating and expansion process, the oven walls of the heat recovery coke oven can withstand pressure. Therefore, the coal charge in the clean type heat recovery coke oven during the coking process has no space for free expansion, thereby promoting the fusion and bonding of the coke. The coal charge in this coke oven is huge, and the coking time is also relatively longer. This is beneficial during the coking process for the precipitation of free carbon and the orderly arrangement of the coke structure, resulting in coke with a better anisotropic coke microstructure. All the volatile matter from this coke oven is completely combusted, so its relative pollution level is much better. Simultaneously, all the volatile matter is used for heating and power generation. Once we understand these process characteristics of this coke oven, we can, based on its process features, specifically design and organize coal resources. If the electricity price at the enterprise where the plant is located is relatively low, and the revenue from power generation is lower than that from chemical byproducts, our choice of coal source would be to increase coke yield and reduce the volatile matter of the feed coal. Conversely, if the electricity price in that region is relatively high, this type of coke oven can actually use more fat coal, 1,3 coking coal, and gas coal, and still achieve coke of the same quality level. Another characteristic of this coke oven is that it typically does not have issues with damaging the oven walls due to excessive expansion pressure or causing difficulties in coke pushing. Therefore, when selecting coal sources, we can choose resources with higher expansion pressure, for example, using more lean coal, anthracite, or meager lean coal. This way, we can utilize this oven type's characteristic of being suitable for coal with lower caking properties and also increase coke yield. This coke oven can fully leverage its advantage of a long coking time to use coal of the same quality to produce larger sized foundry coke with better coke structure and strength. This is another feature of this coke oven. Alternatively, we can increase the usage of non-strongly caking coal to reduce costs. Based on the above principles for coal source selection, we once assisted a coking plant in using feed coal with around 18% volatile matter and some 50 caking index to produce coke. In this case, we blended more lean coal and anthracite, making the production cost significantly lower than the feed coal cost for traditional stamping coke. Simultaneously, through the control and adjustment of the coking time, high-quality foundry coke was produced. We once helped a chronically loss-making enterprise achieve sustained profitability. Well, the above are some suggestions or principles regarding coal source selection for the clean type heat recovery coke oven. If you have any questions, feel free to contact me. See you in the next session.